Welcome to Quadratic Graphs. This is an extension of the topic that we have just completed, topic number 17, functions. This one is topic number 18, and it has to do with quadratic graphs. By the time we are through, then we'll have an idea as to what this topic really entails. This topic will demonstrate how to construct a graphical representation of a function beginning with the algebraic expression that defines it. Knowledge will be brought forward from the previous topic in assisting us to achieve our goals. We have this function f of x is equal to x squared minus 2x minus 8, and our duty is to graph this function. Now we are going to graph this function in the region specified by -3 is less than or equal to x is less than or equal to 5. Well, we can take a tip from the x being between the -3 and 5 to mean that we may go from -3 to 5 inclusive. However, this is saying that -3 is less than x and x at the same time is less than -5, which is sufficient to say that x is between -3 and 5 inclusive. Now let us see if we can develop some pictorial representation, probably in a table, to determine what that really means. So we are going to look at something tangible to which we can allude in order that we may be able to see or get a better understanding of what that means. So we are going to use a table to calculate the values of f of x that we are going to be using to construct the graph. So we're going to be using a table. So that is the frame of the table. Now in that table we intend to have visible values of f of x and values of x. As a matter of fact, we have values of x first and the corresponding values of f of x that will be determined by calculation. So the expression -3 is less than or equal to x is less than or equal to 5. That is how it is read. It means that we are going to start at -3 and end at 5, and the table is going to show that also. We will therefore substitute values of x into the function beginning at f of -3 and ending at f of 5. So let us put those values inside of the table. And of course, those are the values that we have of values of x. So we are going to determine corresponding values of f of x. There we have our table. What do we do? Just as when we were evaluating the function, we are going to evaluate the function again. So evaluate the function for each value of x in the table. So we have f of x is equal to x squared minus 2x minus 8. Therefore, we are going to say f of -3, where we are going to begin right there. F of -3 is equal to -3 squared minus 2 times -3 minus 8. Just as we have just done in topic number 17. There it is. Now we are going to simplify that. So in simplification, -3 squared, negative multiplied by negative is positive. We are going to have a positive 9. Then we have -2 times -3. So -2 times -3 is a positive 6. And then that -8 goes there. The answer is 7, and it is placed inside the table. So we have 9 plus 6 minus 8 is equal to 7. 7 is going to be placed in the table. Then we are going to do the same with -2. So we're going to have f of -2 is equal to -2 squared minus 2 times -2 minus 8. So let's see how that is done. So -2 squared minus 2 times -2 minus 8. So what do we see? This is equal to 4 when we square it. This is also a positive 4. So we're going to have 4 plus 4 minus 8, and that is equal to 0 as indicated right there. Oh, the 0 goes into the table also. Now we do the same with -1. -1 squared minus 2 times -1 minus 8. And it simplifies to -5, and that goes into the table also. We do the same with 0. The terms that have 0 will be equal to 0. The answer is -8, and it goes into the table like that. And of course, we are going to continue, go on and on. So f of 1 is equal to 1 squared minus 2 times 1 minus 8, and that goes into the table also. So we are continuing until we have every single thing in the table. Go to the next slide, and we are going to complete the table when we get there. So we have f of 3, 3 squared minus 2 times 3 minus 8, and then we simplify the result, and 5 goes right there. 4, f of 4 is equal to 4 squared minus 2 times 4 minus 8. So we're going to say 4 squared is 16, 2 times 4 is 8, minus 8. That will give 0, I think. So 16 minus 2 times 4, which is 8, minus 8. That 0 is going to take its position in the table also. And finally, f of 5, 5 squared minus 2 times 5 minus 8. And of course, let's see what it's equal to, 7. And that takes its position in the table also. The table is completed, so what do we do? In the next exercise, we will use a more efficient method to calculate the values. All values are calculated together instead of one at a time. Most times, examiners give tables in which most of the values are already calculated, instead of using a method that calculates all values at once. The few values that remain will take a much shorter time if calculations were done one at a time. In the rare case that all values are to be calculated, the second method that we are going to be taking a look at will be used. Now, before we can put our points on the axes, we'll have to take a little overview of the rectangular coordinate system and see what it means. Now here we have our rectangular coordinate system. The rectangular coordinate system is a system to be used to uniquely identify the position of a point. The position is given relative to two directions. The two directions are represented by two lines that are mutually perpendicular to each other. The lines are called axes. So if we look in this diagram that we have over here, we will see our first axis. There it is. Right. So that is your horizontal line, and it is called the x-axis. The other line is called the y-axis, and it is a vertical line. So there it is, your y-axis. When the algebraic representation of a function is to be transformed to its pictorial representation, the y-axis becomes the f of x axis. So we may remove that y-axis and we replace it with the f of x axis. In identifying a point, we begin at the center of the system, and the center of the system is called the origin, right there. So we're still looking at the rectangular coordinate system. When locating a point, reference is first made to the x-axis. This reference is a number called the x-ordinate. The second number is a reference to the y-axis and tells the position of the point relative to the y-axis. So take a look at your arrow again. There it is. If the x-ordinate is positive, the motion in locating the point is in the positive direction or to the right. And that is what that arrow is saying. So if the x-ordinate is a positive number, you are going to go to your right or in the positive direction. If the number is negative, that is your x-ordinate is negative, the motion is to the left or in the negative direction. What about the y's? If the y-ordinate is positive, the motion is in the positive direction or upwards. A negative y-net means that the motion is in the negative direction or downwards. So let us see how we are going to put our points on the axes. What do we have right there? The first point will be based on the first pair of coordinates. They are called coordinates because they work together. They cooperate with each other. So there you have. Now, you notice that we have a negative 3, 7, the x is negative 3, and the f of x is 7, or the y-axis. So, it requires us to move 3 steps in the negative x direction, and the arrow is showing it right there on your right. There you have another arrow going. Now, this is followed by 7 steps in the positive y direction. So, that is 7 in the y direction. Notice that right here, we have each one of these big squares, or this big block that we have here, means 2 units. So we have 2, 4, 6. On the horizontal axis, each one of the same movement is represented by a single unit. Don't forget that. Now we are going to mark the position with the point. So at the end of the movements, mark that with a point. The second point will be based on the second pair of coordinates. Negative 2, 0. X is negative 2. The y-axis, or the y direction, is of course replaced by f of x. So the f of x value is 0. Now it requires us to move 2 steps in the negative x direction. The y-ordinate is equal to 0. This means that there is no upward nor downward movement. The point is therefore dependent on the movement in the x direction only. So we move in the x direction and we mark our point right there. The third point will be based on the third pair of coordinates. What do we have? Negative 1. So it requires us to move 1 step in the negative x direction. This is followed by 5 steps in the negative y direction. As usual, the point is marked at the end of the movement. So the point is right there. The fourth point is based on the fourth pair of coordinates. The x-ordinate is equal to 0. We conclude that there is no movement in the x direction. So first, we do not have any movement in the x direction. So we are right there at the origin still. So wait for the y movement. There is a movement by 8 units in the negative y direction, which is downwards, and the point is placed at the end of the movement, as usual. So the next point is 1, negative 9. Notice how the point is represented by 2 numbers, representing the 2 coordinates, enclosed in parentheses and separated by a comma. The x-ordinate is written first. So we see there that the points are expressed as 2 numbers in brackets separated by a comma. The x1 goes first, the y is next. Our first movement is by 1 unit in the positive x direction, or to the right. This is followed by 9 steps in the negative y direction, or downwards. The end of the movements mark the position of the point. The next point is 2, negative 8. Our first movement is by 2 units in the positive x direction, or to the right. And we have that with the arrow. And downwards like that. It is followed by 8 steps in the negative y direction, or downwards. There you go. The end of the movements mark the position of the point, and we have done that. And we are continuing. The next point is 3, negative 5. So our first movement is by 3 units in the positive x direction. or to the right. Then our next movement is 5 steps in the negative y direction or downwards. And at the end, as usual, we will place our point. The next point is 4, 0. This is a point with y ordinate equal to 0. This means that there is no vertical movement. Knowledge can be transferred from plotting the second point. See the second point right here? It has 0 f of x ordinate or y ordinate also. Therefore, we can plot it in the same way or similar way to the one that we have plotted before. So we move 4 units in the positive x direction, and what will happen next? We do not move anymore, no more movement, and we just mark our point right there. So here we have our next one, finally 5, 7, and of course we move 5 units in the positive x direction, and then we move by 7 units in the positive y direction. After this, we mark the position of our points, and we have all our points. Therefore, we are ready to draw our curve or to graph the function. After plotting all of the points, we complete our task by drawing a smooth curve through all the points. There you have it, your smooth curve, as smooth as can be. Now, we are going to graph another function, and we are going to complete a table. So what do? We have our function there, f of x is equal to 2x squared plus x minus 6. And where are we going to do that? We are going to graph that function in the region specified by -4 is less than or equal to x is less than or equal to 3. So we know that we are going to go from the value of x, which is -4, and we are going to end at the value of x, which is equal to 3. So let us put the frame of the table, and let us put some information in there. What is the meaning of all of this? So this is as promised. The method will take a shorter time, calculating all of the values of f of x together. The equation is written in a vertical form in the first column of the table. The elements of the first column will tell us what to do with the values of x that are written above. So here is our function here. So what do we have first? Let's see what we have first. We have x, and these are the values of x, going from -4 to 3, -4 to 3. What do we do next? We are writing the function in the table. So we are writing 2x squared there. We have that 2x squared. Plus x goes next. Then we have -6. And of course, at the end, we are required to have the values of f of x. Now, we have 2x squared. That means we are going to square x and multiply the result by 2. So let us do that. So as indicated, we square each value of x and multiply the result by 2. So what is our first value? -4. So imagine that we have it there. So we have -4 squared, and the result is multiplied by 2. So let us see what that turns out to be. So the square of -4 is 16, so we multiply 16 by 2. 32, yes, 32. Then we do the same thing with -3. What happens? 2 times -3 squared. So we are going to square -3, multiply that by 2. So square this, we're going to get 9 times 2, so we have 18. Good. Next thing, we have all of those values going there. Now, how do we know? -2 squared multiplied by 2. So Negative 2 squared is positive 4 times 2 is 8. So we do it right here. X squared, we square the value of x, then multiply the result by 2. Square this, positive 1 times 2, 2. Square this, 9. Multiplied by 2, 18. So that's how we get all of our answers. So we do that right across. Now that positive x, what does that mean? That means we are going to do with this, with everything that we have here, what this tells us to do. So it says, put a positive x. Now, what does that mean? It means that these values will go here exactly as they are. So at the start of the next row is x. All the values of x will be inserted just as they are. So what would have taken place if this were a negative x? If this were a negative x, we would have negative x. So that would be negative of negative 4. That is going to be negative times negative positive. So that will give a positive 4. And here we'll have, if this is negative x, we'll say negative of negative 3, which is a positive 3, and it goes there. And we will say, of course, right here, negative of 2 is negative 2. Or say this is a 5x. What would we do? We'll say 5 times negative 4 is negative 20, and it goes there. 5 times 2 is 10, will go there. Or we may say 5 times negative 1 is negative 5, and it will go there. So what we have here is dependent on what we have here. Since positive x is just x, we just put the values of x in the table just as they are. So what is this negative 6 saying to us? Next is negative 6. This does not depend on x. The entire row will have negative 6 in each cell. So the negative 6 is not affected by x. So irrespective of what the value of x is, it will never have any effect on that negative 6. Therefore, in all that row, we'll have negative 6. Right. Now, how do we get our value of f of x right there? Now, f of x is equal to this. All the sum of our calculated value. Do not forget that these values here are the initial values that we are using to do our calculation. So you do not put these, you do not put this negative 4 along with these. What do you do then? 32 minus 4 minus 6. So 32 minus 4 minus 6 is 32 minus 10. So 22 will go there. Let's see. The final row has the values of f of x and is the sum of the results in the 3 rows. So we have 32 minus 4 minus 6, 22 goes there. Next, 18 minus 3 minus 6 goes there. Of course, 18 minus 3 minus 6 is 18 minus 9, which is equal to 9. Or we may say 18 minus 3 is 15, minus 6 is 9. 8 minus 2 minus 6 is 0, that goes there. This one we have 2 minus 1 minus 6, that gives a negative 5. It goes right there. Right there we have 0 plus 0 minus 6, and that will give a negative 6. And of course we may finish the table in that same manner. Do not forget that this row that we have up here, these represent our initial values that were given to us in the first place and are not a part of the calculation of the values of f of x. Now, the resulting curve is shown on the left. So the curve that will result from the table that we've had is the one that we have here. We have seen in the previous example how this is graphed by making use of the x and y ordinate. You may practice this graph on your own in order that you can have your own representation and you may have your own plot.